Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so for this problem, we're going to calculate what the wavelength is and then determine if it would be within the range of 400 to 1700 nanometers. So for part A, we are given a value of V is equal to 4.35 times 10 to the 14th. And so we're going to calculate the wavelength. So we will use the equation of wavelength is equal to C over V, where C is our constant of 3 times 10 to the 8th. V is what was given. And then if we divided that out right now, it would be in terms of meters, but we need it in nanometers. So we're also going to multiply it by 1 times 10 to the 9th to get it in terms of nanometers. And when we do that, we get an answer of 690 nanometers, which means that yes, it would be detected because it is within that range. Then for part B, we're given something different. We're given our energy, which is 43 kilojoules per mole. And it's important to note those units because we need to first put it in terms of joules per mole. So if we multiplied it by 1,000, we would get 43,000 joules per mole. And then we want it in just joules. So if you multiply that by 6.022 times 10 to the 23rd, which is Avogadro's number, to get rid of the moles, we will get an answer of 2.59 times 10 to the 28th joules. So now we have energy in the unit that we want. So we can use the equation of wavelength is equal to H times C over E. So H and C are both constant. H is 6.626 times 10 to the 34th. C is a constant of 3 times 10 to the 8th. And then our energy is what we just calculated in terms of joules. So 2.59 times 10 to the 28th joules. And then we will also need to multiply that by 1 times 10 to the 9th in order to get it in terms of nanometers. And then when we multiply all of that out, we get an answer of 7.68 times 10 to the negative 45th nanometers. So that is a big no. It will not show up in that range. And then the last part of part C, we're given our V is 706 tetrahertz. So that is equal to 706 times 10 to the 12th hertz. And those hertz are also the same as inverse seconds. So we're going to use the equation that wavelength is equal to C over V, where C is 3 times 10 to the 8th. V is 706 times 10 to the 12th. And then the last step will be to multiply it by 1 times 10 to the 9th to get it in terms of nanometers. So we get 425 nanometers, which means yes. So A and C will show up in the range and be detected.